Welcome to our lecture on introductory ggplot. ggplot provides a so-called grammar of graphics. Now, what does that mean? Well, base R has a large number of simple plotting functions, and these functions can allow some really fine-grained control of your results. But quite often, these are tedious and cumbersome to use. ggplot2 makes it easy to create beautiful graphics with minimal effort. Now you might be wondering, why is it called ggplot2? If so, you can click on this link on the slide. Both ggplot2 and dplyr are part of a family of R packages called the tidyverse. To install the whole group of packages, you can use the command install.packages tidyverse. And to load all of the packages in this family, you can use the command library tidyverse. We'll meet more packages from the tidyverse family later in the course. As usual, I have a large number of references for you about ggplot. There's some good chapters in the book R for Data Science. There's also a really nice book called Data Visualization: A Practical Introduction, which is mainly aimed at social scientists. It shows you how to make some really advanced and beautiful graphics that go well beyond what we'll do in this course. I would strongly recommend that you take a look at that one. There's also a ggplot book, there's a ggplot cheat sheet, and there's the homepage for the ggplot package. Now, don't panic. ggplot syntax takes a little bit of getting used to. The reason is that you are not simply telling R where to put points on a plot. Instead, you are explaining the logical structure of your graphics. So there is a bit of a learning curve, but it's worthwhile. ggplot uses a pipeline-like syntax, but rather irritatingly, it works with the plus sign rather than the R pipe. This is unfortunate. It is a common mistake to get them confused, but fortunately, more recent versions of R are pretty good at noticing the mistake and pointing it out to you. So remember the Gapminder dataset from our lecture on dplyr? Well, we're going to take a look at it again, and we're going to filter the year 2007. So we're going to select only the rows for which observations are from the year 2007. Here is a really simple scatter plot based on this data set. So let me show you how it works. First, I have this command ggplot, and you can see inside of that command I have supplied some slightly complicated looking things. Don't worry, we'll unpack them one by one. So I say data equals Gapminder 2007. That is my tibble that contains only the year 2007 from the Gapminder dataset. Then I've got this thing that says mapping. Mapping equals AES. Okay, that's a bit weird. X equals GDP per cap. Y equals life exp. Okay, so it looks like I'm setting the x-axis to be the column GDP per cap from my tibble Gapminder 2007, and then I'm setting the y-axis to be life exp. And indeed, that's exactly what's happening. Finally, I've got this plus sign, which, as I mentioned before, is kind of like a pipeline type command, but it's not the same one we've seen already. And then I have this other funny looking thing, geom point. Well, we're going to unpack this syntax very soon, but for the moment, just notice that I've ended up with a really nice, really clean scatter plot. Now, the way that I did that last command was to explicitly pass my tibble inside of the, pass it into the ggplot command. The first argument of the ggplot command is indeed the tibble or data frame that you want to work with. But as we know from our lecture on basic dplyr, we can use the pipe to supply the first argument to a function. So now I'm going to pipe in Gapminder. So I've got Gapminder 2007, the pipe. Then I have the ggplot command. And again, somewhat irritatingly, now I have to start using a plus. Once I'm inside the ggplot side of things, I have to stop using the pipe and start using a plus. I have my geom point, and there is my scatter plot of life expectancy against GDP per capita. It seems to have some kind of non-linear relationship, where at first the life expectancy gets much higher as I move to the right on the GDP per capita axis, and then it sort of starts to level off a bit, although it does still increase on average as I move from left to right. Okay, now it's your turn to try a little exercise. As usual, pause the video, take a couple of minutes, and then check your work against the solutions on the course website. Well, I mentioned that the last plot showed a little bit of a nonlinear relationship, and sometimes when relationships are nonlinear, it can be helpful to try transforming the data in some way to get a better sense of what's going on. A logarithmic transformation can often be quite useful, as we know in economics. It can be used for things like elasticities, it can be used for things like growth rates. Here, what I'm going to do is I'm going to log transform the x-axis. So what I'd like to show you, even though we don't quite yet understand what the ggplot syntax is doing, is how easy it is to modify the plot I've already made to get the x-axis to be on the log base 10 scale. All I had to do was add this extra line, number 4, right at the bottom. After geom point, I put a plus, which again is like this sort of pipeline operator. And then I wrote scale underscore x underscore log 10. Don't forget the parentheses. That's actually a function call. And now we see that things, well, they still don't quite look linear, but they look a lot closer to linear than they did before. And you can see that the x-axis has been changed. So now we have 300, 1,000, 3,000, 10,000, and 30,000. So the spacing on the x-axis reflects the log base 10 scale that we're now using. Here's the really nice thing about ggplot, and I've been kind of building up to this with my last example. It allows us to build up a plot step by step. So for example, I could assign the results of that pipeline from a couple slides back to a variable which I'll call my plot. So this is exactly in lines 1 through 3. This is exactly the same command we've already seen. But now I'm just going to send the results of that command into an object called my plot. Now, those lines 1 through 3 won't do anything. They won't display anything, I should say. No plot will emerge if you run lines 1 through 3. But if you go down to lines 5 and 6 and you run those, you will get a plot. So notice what's happening here. I've basically saved a ggplot object inside of this thing which I'm calling my plot. And as soon as I've done that, I can subsequently manipulate the plot in all sorts of ways. So here in line 5, I take my plot plus, which is that ggplot pipe operator, and then I can do my log transform. So that allows us to have a lot of flexibility when we're making plots. We can change our mind later, we can make adjustments, and we don't have to go all the way back to the drawing board every time. It is always a good idea to label your plots. I very often see students when they write MPhil theses with, let's say, figures and sometimes even tables which are not very well labeled, and it can be quite hard to figure out what's going on. So as a good rule, and for this course, whenever you make a plot of any kind, I want you to label it and say what it is. So if I want you to do this, of course, I'd better teach you how. You can add labels to a plot by using the labs command, along with the xlab and ylab command. So these do pretty much what you think they will do. I can provide a title to a plot. If I really want, I can provide a subtitle. I can also add a caption. And I can label the y and the x axes. And again, notice that the way that this works is we're building up a plot step by step. So I'm taking that object I saved on the previous slide, my plot, and I am subsequently adding to it a bunch of labels, title, subtitle, caption, and then I'm adding an x label and I'm adding a y label with the plus operator to separate the elements of this pipeline. Now it's your turn to play around with a little exercise. Why don't you pause the video, spend a few minutes, and see how it goes. We've been using ggplot now for at least a few minutes, but I've said very little about what the syntax actually means, and it does look a little bit forbidding. So now is the time to start unpacking that. What ggplot does is it combines data with an aesthetic mapping and a geom. So what is a mapping? Mapping is the place where we write mapping equals AES and then some other things. So previously you saw that I wrote X equals GDP per cap and Y equals life exp in order to put each of these variables on the X and Y axis respectively. AES is short for aesthetic. So what's happening here is that we are mapping the GDP per capita column of our tibble to the X coordinate of the plot, and we are mapping the life exp column to the Y coordinate of the plot. So we're describing the structure of the plot and how the geometry of that plot is going to work by saying which columns are going to be the x-axis and which are going to be the y-axis. The next thing that we had was geom_point. This is a geometric object, or a geom for short. What a geom does is it uses the mapping to create the scatter plot. So again, first we're sort of setting up the geometry of the plot with the aesthetic mapping, and then we're using that aesthetic mapping to actually do some plotting using the geom. We're going to learn lots more mappings and lots more geoms later on, so the idea for now is just to kind of get your head around the division of labor, if you will, within one of these ggplot pipelines. Okay, so here is another aesthetic that we can provide. We can actually provide color. So remember, the aesthetic mapping is sort of telling us how the information in our data set is getting mapped to the visual elements of our plot. So one set of visual elements is position, x and y coordinates. Those are what we've looked at so far. Another visual element that we can map is color. So what we're doing in this plot is we are making the same picture we had before of life expectancy against GDP per capita on the log base 10 scale, but now we're going to color in the points based on which consonant they are in. And notice that when we've done this, ggplot automatically produces a really helpful legend for us at right. So all that we had to change to get this behavior was to add one more element to our aesthetic mapping. After this y coordinate specification, we put a comma, and then we said color equals consonant. In other words, we told ggplot which column of the Tibble Gapminder 2007 it should use to map colors to. So colors are going to correspond to consonants. We can also change the size of the points. So we can also use size as an aesthetic mapping. So here I'm going to, and this may or may not be well advised, there's quite a lot of information on the plot, but I'm going to use size to denote population. To do that, all I've got to do is add size equals pop inside of my aesthetic mapping. And now, as you can see, I've actually displayed 4 variables on a single plot. Again, the x-axis is on the log 10 scale. And while it's a little bit busy, it's actually fairly easy to see where are the big countries. Well, the big countries are, for the most part in this picture, in Asia. And we can see that they occupy a range, these larger ones at least, that's kind of in the middle on GDP per capita and, middle high on life expectancy. So there's quite a lot of information contained in this plot, and it didn't really take much work at all to build it. In every step, we just use this geom_point exactly as we did before. It's just that now we've specified a more complicated aesthetic mapping to tell ggplot which columns and which information from the Gapminder Tibble it needs to map to particular visual elements in the plot. Now it's your turn, a short exercise to try out some of what we've learned so far. But if one plot wasn't enough, ggplot allows us to make multiple plots at a time. This can actually be extremely powerful, and I just want to show you how easy it is. So in the first line of the code block on this slide, I am taking my Gapminder Tibble, the full Gapminder Tibble, not the 2007 one. I am then going to filter. I just want to select only those rows for which the year is contained in the vector 1952, 1972, 1992. And here is an example of how that in command that we learned in our base R lecture can really come in handy. So remember what that's going to do. It's going to evaluate to true for each element of year that is contained inside of that vector to the right, 1952, 1972, 1992, and false otherwise. So this will just select the rows that have years in that particular range. Now we're going to pipe that into ggplot. I'm going to use exactly the same aesthetic mapping as we had before because we're building this plot up. I'm going to use geom_point and scale x log 10, but now I'm going to use one more thing. I'm going to use facet wrap. So I have facet underscore wrap, and then I have a little tilde. The tilde will make more sense in our future lecture on regression. For now, just, I don't know, ignore it perhaps, and just think about, well, you could think about it as follows. The tilde is showing that year is going to be a grouping variable for making a sequence of plots. That's the way to think about it. And as you can see, what's happened here is we've ended up with not one, not two, but three plots, a different plot for each year, but each plot is set up in exactly the same way. And this was a lot less work than trying to separately subset each of those years and individually make separate plots for each. So ggplot allows you to build up a really complicated and informative graphic fast. Now it's time for you to give it a try. Here's a short exercise. You can pause the slide, and as always, check your answers against the solutions that I've posted on the course website. So far, I have been plotting raw data, but we may sometimes want to plot summarized data. To do that, we can use some of what we learned in our dplyr lecture to construct summary statistics and then pass the result into ggplot. So here I have a somewhat complicated pipeline. I take Gapminder, I create a new column called popmil, which is population divided by 1 million, so population in millions. Then I'm going to group by year and continent and calculate the total population in millions of that continent. So that's what lines 1 through 4 do. They produce a tibble that is going to contain continents and the total population in the continent. Then I'm going to pipe that into ggplot. I'm going to define an aesthetic mapping where the x-axis is year, the y-axis is the total population in millions, and as before, I am going to use color to denote continent. I'm going to use geom_point again because we're making a scatter plot, and I'm going to add a label. So what we can see here is that Asia experienced quite a fast rate of population growth over these years, particularly compared to some of the other continents in the data set. Now, that last plot didn't look very pretty. Usually, you wouldn't make a plot like that with points. You'd make it with lines. And that's really, really easy. So if you take a look at line 6 on the code chunk at the beginning of this slide, you'll see that is the only thing that has changed. The beauty of ggplot is that I can make sweeping changes to my plot with only minimal changes to my code. So again, line 6 is the only thing that has changed. I'm going to reverse the slide to show you this. Notice that geom_point has been replaced with geom_line. Geom_point to geom_line, and that is it. So now you know how to make a scatter plot, and you also know how to make a line plot using these two geoms that you've seen, geom_point and geom_line. It's time to try it out in a short exercise. Sometimes in these exercises, I'm going to ask you to do things that I haven't actually taught you how to do. Now you might be wondering, am I just a really hard-nosed professor and doesn't like my students? Well, no, actually, I like my students a lot, but one of the best ways to learn is to try things that are hard. So sometimes you're going to have to do a bit of searching outside the lecture material to find information. A great place is the R-help files. You can also guess and try things. So in item number 4, think about how you might try to include both points and lines in your plot. We've seen geom_point, we've seen geom_line. It's time for another geom. This one makes a histogram. In other words, a count or fraction of observations that fall into equally spaced bins along the horizontal axis. Now, when we were making line plots and scatter plots, we needed to specify in our aesthetic mapping both x and y. But here, we don't. And maybe you can think about why that's the case. So to make a histogram, we just specify that we want the variable over which we're making a histogram, x equals life expectancy, and then we use geom_histogram. We have to specify a bin width, which is the width of the histogram bins. An important thing to remember about histograms is that they're not really a data summary, they're a model, because they involve choosing the bin width. So you choose different bin widths, you're going to get very different shapes in some cases. If you don't specify a bin width, ggplot will try to pick one for you and warn you that what it did may or may not be very good. But here I've chosen a bin width of 5 years along the life expectancy axis. If we change the bin width to 1, we can see a lot more, but in some sense, we're kind of overfitting the data here. We're seeing a lot of variation, but much of this variation is probably, it could indeed be year-to-year variation. It might not be very meaningful. You know, arguably this bin width of 1 is a little bit too small to really see the overall pattern of what's going on. But don't hold me to that. That's just based on eyeballing this picture. I'm not an expert in life expectancy. And as usual, here's an opportunity for you to try it out yourself. We've seen geom point, we've seen geom line, we've seen geom histogram. Now it's time for box plots, everyone's favorite kind of plot. A box plot contains a box, which represents the middle 50% of the data, and it contains whiskers, these little sticks that point out at the sides, that indicate the maximum and the minimum. I always think these kind of look like TIE fighters from Star Wars, but sadly, no one else seems to agree with me. The lines that delineate the box correspond to the 25th percentile and the 75th percentile, whereas the thicker line in the middle corresponds to the median. So the box plot is showing us the middle 50% of the data, and it's also showing us where the median is. Sometimes you will actually see dots. In this particular one that I made, you don't, but sometimes you will see them. These dots are observations that are more than 1.5 times the interquartile range from the box. In other words, points that are more than 1.5 times the width of the box away from the box. This is the default behavior in ggplot to just try to make you aware of points that seem to be somewhat unusual. That doesn't mean that they are outliers that you should ignore or anything like that. They're just points that you might want to take a look at. So to create this box plot, again, a box plot is only summarizing one variable, like a histogram, so our aesthetic mapping only specifies one thing, life expectancy in this case. And the new geom that we have learned is geom box plot. One of the great things about box plots is that we can use them to quickly compare groups. Now we are going to have to specify another variable inside of our aesthetic mapping. So here the x variable is the one that runs along the horizontal axis, and the y variable is the one along the vertical axis. So the variable we are making a box plot of is the y coordinate, and the variable we're using to group is the x coordinate. Here we are looking at life expectancy by continent, and so we can see the variation in a really nice way. We can see, for example, that in Oceania there's almost no variation. There's also very little variation, relatively speaking, in Europe and the Americas compared to Asia and Africa. We can see those in addition to the medians, and in this particular plot you can see a couple of points that are more than the specified distance away from the box, so they're being shown by R. Now it's your turn. I'd like you to try to use faceting to construct a collection of box plots, each of which is comparing log GDP per capita across continents in a given year. We've seen box plots, we've seen histograms. Now it's time to make bar plots. To make a bar plot, we use geom_cal, and in this case, the x argument of the aesthetic mapping has to be a categorical variable. So what I'm going to do here is I'm going to construct this tibble by continent, which gives the mean life expectancy by continent. That's in lines 1 through 4. Then I'm going to pass that on into ggplot. I'm going to specify x is continent, y is mean life expectancy, and the key thing here is that x is a grouping variable. It's not like a continuous variable like GDP per capita or something like that. It's continent, so Africa, Americas, Asia, Europe, and so on. Other than that, the only thing that changes is I now use geom_cal rather than one of the earlier geoms that we've learned. It can actually be quite helpful to turn a box plot on its side. In ggplot, you can, sorry, it's not a box plot, it's a bar plot, pardon me. It can be quite helpful to turn a bar plot on its side. It makes it a bit easier to read what we really care about, which is the life expectancy in this case. To flip any plot in ggplot on its side, you just add coord flip. The nice thing about ggplot is that all of these different commands you're learning are all modular. They can be combined in so many different kinds of ways to produce a really wide variety of different kinds of plots. Now, so far, we haven't been tweaking any of the visuals at all. We've just been taking the default ggplot theme. But actually, ggplot is incredibly customizable. So one theme that can sometimes be useful is theme BW, which stands for theme black and white. And if you notice what has changed from the last slide to this slide, it is just line 5 of the code chunk. And you see what has happened, it has somewhat simplified the design. So whereas previously we had this kind of light gray background with white gaps to show the divisions along the axes, now we no longer have that. We have a white background with gray lines to show those divisions. There are many, many different themes in ggplot. You can experiment till your heart's content. And if you'd like to learn more about them, you could take a look at the R help file for theme by typing $theme at the console. And now it's time for another exercise. Okay, this one is a little bonus extra just because I can't help myself. In my view, bar charts are inferior to Cleveland dot charts. And if you want to learn about Cleveland dot charts, you can click on the link on the slide. So what is a Cleveland dot chart? Well, I am going to make something that looks very much like a bar plot in some ways, which I've got a grouping variable, and then I've got a kind of a y coordinate. So I've got an x and y coordinate. But now I'm going to use geom_point. So previously when we made a bar plot, I'll just show you over here, we used geom_col. Now I'm going to use geom_point. And you'll notice that there's just a much less busy plot. I can see the points, and there's just less chart junk. It's just much easier to read everything. You may, in fact, find it helpful to sort the information in your dot chart. And if you want to do that, this is a little bit complicated, but there is a command from the package called forcats that you could click on here and read about, called fct reorder. You can use this to sort the elements of your dot plot by mean life expectancy, as I've done here. Again, it's a little bit advanced, but it can be helpful because in the previous plot, we just showed the continents in alphabetical order, but there's no reason to waste the opportunity to provide useful comparative information. We're not interested in how life expectancy changes based on the first letter of a country's name. We might be interested in knowing which continent has the highest and lowest life expectancy, and sorting them in this way makes it much easier to see that. So whenever you're making a plot, and I wish this is something that we had more time to spend on in the course, but you should think about what rhetorical work you're trying to do. You should think about what you're trying to communicate and what sorts of comparisons your audience is likely to want to make with the information you're providing. You should then design your graphic to make it as easy as possible to draw out that information. So here, my assumption is that people might like to find out which continent has the highest and lowest life expectancy very easily. And by sorting things in that order already, I've made their life much easier. Now, this one is really a bit Baroque in its complexity, but I couldn't help myself, so here it is. I'm not going to explain all 11 of these lines of code, because really this is just an addendum to the video that I'm adding just to please myself. But here is a more complicated and interesting dot chart, and in this one, I've actually shown how the life expectancy changes from 1987 to 2007 in each of these continents. It's very simple. I think it's quite elegant. And it's really worth thinking about what sorts of designs you might want to come up with to display the comparison that you find relevant or interesting in the data set that you're working with. I do have one exercise for you about dot charts, so please indulge me and give this one a try. Okay, when you have made your masterwork, you probably want to save it. So there is a command for this. It's called ggsave. You enter the file name that you want to save your plot as. You can also specify the width and the height. This is going to default to saving the last plot that you made. You could also specify precisely which plot you want to save. For example, earlier on we created a plot that I called, I think, my plot. So you could specify plot equals my plot to tell this ggsave command that you would like it to save that one. The argument file name to ggSave is both the path on your system to where you would like the file to be saved and the file name itself. So that includes the file extension like JPEG, PNG, or PDF. And indeed, all of those different kinds of files are supported by the ggsave command. And that brings us to the end of our lecture on the basics of ggplot. As always, there is much more to learn, and we will see many more examples of ggplot in context throughout this course. But I can't cover everything here, so you will need to do a little bit of reading on your own. I've tried to encourage you to get started on this with the exercises this time around by not quite telling you everything you needed to solve all of them. So a great place to get started if you want to learn more would be to take a look at the references at the beginning of this slideshow.